Okay, so for the finding the maximum area deal, so you're gonna have a rectangle, okay? Now your one side of your rectangle is gonna be 2x, right? Because x will just be half of it, and then one side of your rectangle is gonna be y, okay? So your area of this rectangle is going to be 2x times y. And I want to make that number as big as possible. Okay? So we know what y equals because it's given to us as the curve. So then we're just going to go ahead and substitute that and then just multiply the 2x out. Okay, so we have 24x minus 2x cubed. So now the way you find the maximum area is you're going to derive something, you're going to derive whatever curve you have, and then set the derivative equal to 0. And the reason you do that is because when you have a derivative, when the derivative equals 0, that automatically means that you're at a high or a low, right? Because if that hits 0, then it has to go, then change directions. Otherwise, it's never actually 0. If that didn't make sense to you, just forget that last part. But anyway, so you set the derivative equal to 0. So first we're going to take the derivative, 24 minus 6x squared. Set that equal to 0. So 24 minus 6x squared equals 0, and then solve for x. Okay, so we get x equals 2. Then all we do is we plug that 2 back into the formula for area, and we end up getting 32 units squared. Now, here's something they don't usually tell you about this. Whenever you're finding the maximum area of a rectangle, that maximum area will always be a square. Now, there was a shortcut that I kind of made up once I found that out, and I can't actually remember what it was. It's pretty simple, and you just have to manipulate these figures somehow. I don't know what it is, but if you could figure that out, it would make your job a lot easier. I'll think about it some more, but I'm not sure if we'll be able to come up with it. But if not, then this is how you do it. So long story short, take the derivative of the area, set it equal to 0, and that's your answer.